In this video, let's talk about system of parallel cells and EMF of the equivalent battery and the proof of the formula for equivalent EMF. Okay, so here we can see a system of parallel cells. There are three batteries in parallel. That means potential difference across each battery is same. And here if we consider the equivalent EMF or the equivalent battery, so let's say this is the equivalent battery, have EMF E and the internal resistance R. Then the EMF is related as E equals E1 divided by E over R, EMF of the battery divided by the internal resistance of the equivalent battery is equals to E1 divided by R1 plus E2 divided by R2 plus E3 divided by R3. Okay, so now let's try to prove this. So write proof. Now to get to the proof, the one thing that we want to understand, if I send a I current here, say I'm sending I current through this, so this I current will be divided into three directions or into the three wires. So here the current I1, let's say, and this is I2 and this is I3. And now from Kirchhoff's first law, that is the Kirchhoff's current law, we know for a node or a junction, the current coming in is equals to current going out from the junction. So here the whatever the current comes into the junction is equals to the sum of currents going out from the junction. So we have this relationship. Let's keep it aside. Okay, and then I can write down the potential difference. Now we know all these have the same potential difference. Let's say that is V. So V is the potential difference across this, and that is going to be the same potential difference across the equivalent battery as well. Okay, these things we should know. Okay, now here the voltage I can write. So this current is I1, means here the current is again I1, and here current I2, and this current I3. Again these two sum up here, and then it gives again the current I. Okay, so now I can consider this battery and write down the potential difference. Since current is coming out from this battery, I can write V equals E1 minus I1 R1. And similarly, I can write the voltage difference across this and this. So I can write here V equals E2 minus I2 R2, and again V equals E3 minus I3 R3. So from this relation I can subject currents. Okay, so here I get I1 equals E1 minus V over R1, I2 equals E2 minus V over R2, and I3 similarly E3 minus V over R3. And now finally I can write down the voltage across this equivalent battery. So V equals E minus, so this is a equivalent battery, means it has to give the same electric effect. So the total current coming out from these batteries is I, so the I current should flow through this as well. That is how we define the equivalent battery and equivalent EMF. It has to give the same electric effect, that means same current. So we have here V equals E minus IR. Okay, and now I have 1, 2, 3, 4, these four relations, and here the current formula. Again from this I can write the current I equals E minus V over R. Now I can subject these four relations into this formula. So I get E minus V over R equals E1 minus V over R1 plus, and I2 is E2 minus V over R2 plus I3 is here I3 is E3 minus V over R3. Now let's rearrange this formula, so I can write this down as, here I can write E over R minus V over R is equals to E1 over R1 minus V over R1 plus E2 over R2 minus V over R2 plus E3 over R3 minus V over R3. So here I can write E over R equals to E1 over R1 plus E2 over R2 plus E3 over R3. I take this term, and this term, and remaining, there are 3 terms remaining. In these 3 terms, V minus V is common. Here minus V, here minus V, minus V. So I take that out. So I get the remaining as 1 over R1 plus 1 over R2 plus 1 over R3. Now what is this quantity 1 over R1 plus 1 over R2 plus 1 over R3? That is from our knowledge of system of parallel resistors. We know that is the equivalent resistor. If we have resistors R1, R2, R3, 3 of them are in parallel, then the equivalent resistor R, we can write 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3, right? So here this is 1 over R, so we get E over R, sorry, I have forgot to write this minus V over R here, so minus V over R plus E over R. So E over R minus V over R equals to E1 over R1 plus E2 over R2 plus E3 over R3 minus V over 1 over R. I can write like this. So we can see clearly this minus V over R minus V over R both are equal, cancels off. So the required formula that we want to prove, we obtain as E over R equals to E1 over R1 plus E2 over R2 plus E3 over R3, and where here 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So that is the proof. And now we purposely take all the terminals. Here this side is positive, here the negative. If I consider this battery, and here this side is positive, this side is negative, and again this side is positive and this side is negative. Now what happens, what would be the relationship here if I change the polarity of one of this battery? Let's say we are going to change the polarity of this battery. So what is the formula that we will get? To learn and understand what would be the formula for in that case, you can watch this video appearing here.